Right now, you are having a thought. You don't know where it came from, you didn't choose to have it, it simply appeared inside your mind, fully formed as if it were placed there, and you called it yours. Now here's the question that some of the smartest people alive have spent years trying to answer and haven't. What if that thought and everything around you, the room you're in, the weight of your body, the light hitting your eyes right now, what if none of it is real, not in the way you think? What if you are not a person experiencing a universe? What if you are a process running inside one? This is not science fiction. This is a serious scientific hypothesis, and the deeper you go into it, the more it stops feeling like a thought experiment and starts feeling like something you can't unthink. In 2003, a philosopher named Nick Bostrom at Oxford University published a paper. It wasn't long, it wasn't complicated, but it shook cosmology, philosophy, and physics in a way very few papers ever have. His argument was simple. One of three things must be true. Either almost every civilization in history goes extinct before it develops the technology to run realistic simulations of conscious minds, or almost every civilization that reaches that point decides for some reason never to run those simulations, or we are almost certainly living in a simulation right now. He called it the simulation trilemma, and here's what made it different from every other what if we're in a matrix conversation people had in college dorms in the early 2000s. This wasn't philosophy for its own sake, this was mathematics. If even one civilization ever runs a single realistic simulation of conscious minds, the number of simulated minds will eventually outnumber real ones by billions to one. Statistically, you are far more likely to be one of the simulations than one of the originals. Bostrom wasn't saying we definitely live in a simulation. He was saying the odds are not in our favor. But that wasn't what made physicists nervous. What made physicists nervous was what they found when they stopped looking at the stars and started looking at the code. In 2012, a theoretical physicist named Silas Bean at the University of Bonn was running large-scale simulations of quantum chromodynamics, the physics of quarks and gluons, the particles smaller than atoms, and he noticed something. His simulation had a limit. There was a smallest possible unit of space the simulation could model. Below that scale, the math broke down. The simulation couldn't go further. He already knew that. Every simulation has a resolution limit. What stopped him cold was what happened when he compared that limit to what we observe in the real universe. Because the real universe also has a smallest possible unit. It's called the Planck length. Below that scale, space itself stops making sense. Physics breaks down. No instrument ever built has measured anything smaller. And the pattern of cosmic rays, high-energy particles that stream in from deep space, showed a directional bias that precisely matched what you would expect if space itself were arranged on a three-dimensional lattice, just like a simulation grid. Bean published the paper. He was careful with his language. He wasn't claiming we live in a simulation. He was saying the evidence was consistent with one, but the implications sat there in the data like something that couldn't be unsaid. The universe has a resolution limit, just like every simulation ever built. This is where it gets darker, because if we live in a simulation, certain things about the universe that have always seemed mysterious suddenly stop being mysterious. They start looking like design choices. Take the speed of light. It's a constant. Nothing in the universe travels faster. But here's what physics has never adequately explained. Why that specific number? Why 299,792,458 meters per second? There's no equation that requires it, no deeper law that demands it. It's just a constant that exists, a hard cap, a ceiling. In a simulation, you'd expect a hard cap on information processing speed. You'd expect it to look exactly like a speed limit built into the fabric of space itself. Or take quantum mechanics. At the smallest scales of reality, particles don't have definite positions or states. They exist as probability clouds, pure potential. And here's the part that most physics textbooks glide past. They only resolve into something real when they're observed. Physicists have spent a century arguing about what this means, but one interpretation sits quietly in the back of every classroom. What if particles only render when something is looking? What if the universe only bothers to compute the details of reality when a conscious observer demands them? That's not a spiritual idea, that's a programming optimization. Any game developer in the world will tell you the same thing. You don't render what the player can't see. It's a waste of processing power. But here's the part that almost nobody talks about. Because even if all of this is wrong, even if every physicist who takes simulation theory seriously is missing something obvious, there's still a question sitting underneath all of it that won't go away. If we are not in a simulation, we are almost certainly going to build one. We already build games with physics engines. We already run models of neural networks that exhibit behavior their creators can't fully explain. We already have computers that can simulate proteins folding, galaxies forming, economies collapsing. We are decades, maybe a century away from running simulations complex enough to ask whether the minds inside them are real. And when we do, those simulated minds will look up at their universe, see its laws, run their own experiments, and wonder. They will build their own philosophers who argue about whether reality is real. They will build their own physicists who notice the resolution limits of their space. They will build their own Bostroms who write papers that make everyone deeply uncomfortable at breakfast. And from inside, they would have no way to know, just like you have no way to know. The question that tends to stop people is this one. Does it matter? If the simulation is indistinguishable from reality, if you feel pain when you're hurt and love when you're loved, and time passes and people die and new ones are born, and the whole weight of existence sits on your chest at 3 a.m. the same as it always has, what exactly would change if you found out it wasn't real? Most people answer nothing, but that's the wrong answer, because here's what it would actually change. It would mean that somewhere, outside the edges of everything you've ever known, there is something real, a deeper level, a place where the rules of your universe are just parameters in someone else's code, where what you call the laws of physics are just settings in a menu, where the thing you call consciousness, the voice inside your head reading these words right now, was assembled deliberately for reasons you were never meant to understand. You wouldn't just be a person in a universe, you would be a thought in someone else's mind, and everything you've ever done, everyone you've ever loved, every moment that felt like yours, it was always theirs. There is no clean resolution to this, no equation that closes the loop. The simulation hypothesis doesn't offer comfort or answers, it offers something far more unsettling, the possibility that the deepest question a human being can ask, why does anything exist at all, has an answer, and the answer is someone else made it. We built telescopes to see further, we built particle colliders to see smaller, we built computers to model the universe itself, and somewhere along the way we arrived at the edge of the map and found something that looked less like an abyss and more like a wall. The universe has laws, it has constants, it has a resolution limit, it only renders what is observed, it has a speed cap on information. Maybe that's just physics. Or maybe you're not looking at the universe. Maybe you're looking at the code.